All right, you guys have 2 web assigns. They are both due on Friday. I just posted 6.1. You can do all of 6.1 when I'm done teaching this. So do not wait until Thursday night to then try and do it all and say, well, I didn't get it all done. I'm not taking anything late. You have today till Friday morning to get the 2 lessons done. You can get them done. I'm just giving you guys plenty of time. All right, so 6.1, we're talking about the law of sines. You guys have seen this in geometry. Some of you are going to say, I don't remember it. That's fine. You're going to be given the formulas, so you'll know what to do. But every problem is going to start out saying, using the law of sines, or using the law of cosines, so you'll know which one to use in a given situation. But we have to use the law of sines, law of cosines, when we're dealing with oblique triangles. So you're like, what does that mean? All right. All an oblique triangle is a triangle that doesn't have what? Doesn't have right angles. That's it. You cannot use the Pythagorean theorem in this case. You cannot say a squared plus b squared equals c squared because there's no right angle. So you have to use different formulas. In an oblique triangle, it's a triangle that has no right angles, okay? We also need to be familiar with notation. Look what I have highlighted in green versus what I have highlighted in red. You guys see the difference? What's the difference in just how they look? Capital and lowercase, okay. The capital letters are used for what parts of the triangle? Angles. The lowercase letters are used for what? Sides, okay, because sometimes there's no pictures drawn, so you have to know lowercase b means side b, not angle b. Another thing I want you guys to pay close attention to. What side is across from angle A? Side A. What side is across from angle B? Side B. What side is across from angle C? Side C, right? So if they give you an angle and a side, you know that they are across from each other. You have to know where to place these things. Another thing we need to remember, how many degrees are in one whole triangle? 180 degrees. That is very, very important for you guys to remember. There's 180 degrees in one triangle. All right, now the rest of this is going to be just calculator work, setting things up and putting it in the calculator. We're going to solve all different kinds of triangles. You guys did this in geometry where you had to prove that triangles were congruent using side, 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 angle, side, da, da, da. We are not doing any of that. You're just going to be given different types of triangles, meaning sometimes you'll be given all 3 sides. Sometimes you'll be given a side with 2 angles, that sort of a thing. In this case, the side, 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 you have to use the law of cosines. There's no other thing you can do. The rest of them, we're going to use the law of sines. So we're going to do law of cosines tomorrow, and you're going to see it's really easy, but it's going to say using the law of cosines or whatever. So just make sure you guys are paying attention to what it says. All right, the law of sines can be written 2 ways. Look, here's the law of sines. You'll be given it, but there's nothing really to be given. What do you notice? Okay, lowercase over the big, good. What stays together? The A's are with the A's, the B's are with the B's, what? C's are with the C's. All it is a proportion, guys. You're going to be given, in order to use the law of cosines, you have to be given an angle and its corresponding side. That is always going to be where you start. Then you'll be able to find the other stuff. You can write it with the letters, the lowercase letters on top, which is the sides, and then with the angles on the bottom, you can write it like that. Or you can write it like an example, where the angles are on top and the sides are on the bottom. You guys see that? What matters is that A is with A, B is with B, C is with C. What matters is if you decide that all the angles are going to be on the top, then all the angles have to be on the top. And if you want sides on the top, then the side. Everything has to have some sort of pattern to it. You just can't be arbitrary and just put stuff wherever. Now, everybody look on your calculators. Everybody look at your calculator. If you don't have one, there is a sine button. There's sine, cosine, and tangent, right? Here's your sine button. Above your sine button, do you see this? Do you know what those are of each other? These are inverses. So when you get to the point where you come out with a number, and we're going to get to an example like this, it'll be like sine of 64. Put that in your calculator. Everybody hit right now, sine 64, and tell me what you get. 0, so 0.897?
898.
0.898. Okay. When you guys are working this out, what will happen is you guys will get this as an answer. You'll have like sine A equals 0.898. Does that make sense? That an angle measure is 0.898? No. Because you're not actually finding A, you're finding the sine of A. So what, in a sense, you're going to do is you're going to take the inverse, the opposite of each side. So in your calculator, hit second sine, so that little -1 comes up, and then put in 0.898 and hit enter. What do you get? 63.89, which is really close to 64, right? So in some cases, you're going to find like A equals 12.3. Or you'll find sine of A equals 0.898. And that's where you're like, oh, wait, it's not the angle A, that's the sine of it. So you have to take the inverse. We'll talk about that a little more in a bit. But that you're going to use that second sine button on your calculator. All right, so let's go over some examples. The first thing I want you guys to do is to identify what you are given. In this case, you're given two angles and one side, correct? You guys agree? If you are given two angles and one side, there's only the possibility of one triangle. We'll talk about this a little more in a minute. But first thing I want you to do is say, okay, how many angles did they give me? How many? So then you say, okay, there's only one triangle present. It's going to be important as we go through these. There's only one triangle. So now we're going to go through. It's going to say solve the triangle. So you have to figure out what's missing. What angle is missing? Angle A, okay. And what sides are missing? Side B and, no, just kidding, sorry. C and A, you said? Okay. So C and A. Those are the pieces of information we have to find. When you're given two angles, it's super easy to find the third one. What would I do? Yeah, I'm going to say 102.3 plus 28.7. What does that give me? 131? Yes? Okay, so then how do I figure out what angle A is? If 131 degrees are already taken up, I say 180 minus 131, and I get what? So angle A is 49 degrees. Anybody have any questions about that? All right, now we're going to use the law of sines. And if you're getting the wrong answer in your calculator, you may be in the wrong mode, so we can fix that. But we're going to use the law of sines. I told you you're going to be given a side and its corresponding angle. So in this first example, what side and corresponding angle do we have? B, right? I have side B and angle B, correct? That's my proportion that I'm going to start off with. Does not matter if you put angle on top or side. I like to put angle for whatever reason. So I'm going to say sine of 28.7 over 27.4 equals. Now, what information do I have that I can use to now find something? Can I find anything out about side or angle C? Yes. Can I find anything out about side or angle A? I already have. So what do you guys want to find? Side A or side C? Doesn't matter. Want to find C? Okay. So you're going to say sine. What's the sine of angle C? 102.3 over what? Whoops. Over little c. Every single time, guys, you're going to use the proportion that they give you, the side and the angle that corresponds, and then you figure out the missing pieces. How do we solve when a fraction is equal to a fraction? You cross multiply. Don't do any calculations till the very end. So I have C times the sine of 28.7 equals 27.4 times the sine of 102.3. Just cross multiply. All of those, sine 28.7 is a numerical value. It's just not pretty, so just leave it. Because you're trying to figure out what side C equals. So how do I get side C all by itself? I'm going to divide both sides by the sine of 28.7. Now, I suggest you guys do not do any stuff in your calculator till this very last step, because the more calculations you do within the problem, the further and further away you're going to get from the actual answer, because it's going to round a bunch. So everybody right now, grab your calculators. Numerator divided by denominator. Do 27.4 times the sine of 102.3 and hit enter. and then divided by sine 28.7. Tell me what you get with a few decimal places. Okay, 55.75. If you did not get that, that's okay. Just let me know and I'll help you. Now look at the problem, guys. What is everything rounded to? How many decimal places? 1? So go ahead and round this to 1 decimal place. What would it be? 7.4. Okay, so go ahead. What would you round it to? 55 point what? 7. And what's the measurement? Feet. So your answer here for side C would be 55.7 feet. It's all stuff in your calculators. Okay, so now we're going to go back and we're going to find side A. Use the proportion that was given to us at the beginning. What was the proportion? Sine 28.7 over what? 27.4? Angle over sides. You can do sides over angles. Doesn't matter. So what information are we going to use for A? How would I set it up? Do I know side A or angle A? I know the angle, so it's going to be sine of what? 49 over what? A. And then how do we solve this? You cross multiply every single time. We're going to do the same thing. So it's A times the sine of 28.7 equals 27.4 times the sine of 49. Now what do? Divide both by the sine of 28.7. So A equals, throw that in your calculator, 27.4 times sine 49 divided by sine 28.7. Say it again. So 43.1. You guys get the same thing? Okay, hang on. So 43.1 feet. All right, so the hardest part about this, guys, is just going to be paying attention to numbers. A lot of you will transpose things, put them in the calculator, and it's a little wacky. These are a little time consuming, but nothing that you guys can't handle. But notice, the first thing you should do is survey the information they gave you, because in this case, they gave us what to begin with? 2 angles and 1 side. When they give you 2 angles and 1 side, the only possibility is 1 triangle, and you'll see what I'm talking about here in a second. So let's move along. It says right here in example 1, you saw that 2 angles and 1 side determine 1 unique triangle. If you are given 2 sides and 1 angle, there's 3 possibilities that could happen. You could have no triangle, you could have 1 triangle, or there could be 2 triangles. You could have something hidden. And I'm going to show you how to go about finding if there is a hidden second triangle. It's called the ambiguous case. All right, when you're given 2 sides and 1 angle. If you have 2 angles, you just add them up, subtract from 180, there's only 1 triangle. But there is a possibility of getting no triangle. There's a possibility of only 1, and then there's the possibility of 2. We're going to do all 3 cases right now. All right, so let's move along. It already tells you the answer at the top, but I want you to follow along with me and see what's given. We're always going to assume that a second triangle could be present. When? When you're given 2 sides and 1 angle. Is this the case when we're given 2 sides and 1 angle? Yes? Okay, so we're going to say, okay, there could be 2 triangles. I'm going to say this is triangle 1 and this is triangle 2, just in case. All right, set it up. Get your mind thinking, okay, there could be 2. If you have 2 sides and 1 angle, you could possibly have 2 triangles. What angle is given to you? Angle A. So if you are given an angle, it will be present in both triangles. So 42 degrees in both. Whoops. All right, that you can already get set. And we're going to see if a second triangle exists. So let's go ahead and use our law of sines and figure out another side or an angle. What angle, what's the only other angle I can try and find? B. Why B? Yeah, I don't know anything about C, right? So let's see angle B in the first triangle and angle B in the second. All right, so I'm going to come over here. What's my proportion that they gave me with my given information? Sine what? Sine 42 over 22, good, equals what? sine of b over 12. Now, guys, look, it says the sine of b. So what am I going to have to do when I get my answer? Do that inverse thing. Do the second sine. Okay, so how do we solve this? Every single time we cross multiply. So 12 times the sine of 42 equals 22 times the sine of b. I want sine b by itself, so I do what? Divide by 22, so I get the sine of b equals. What's 12 times sine 42 divided by 22? Give me the decimal answer. Don't go ahead yet. Just give me the decimal answer. What's the, yeah, what is it? Point what? Give me 4 decimal places. In your calculator, guys, come on, everybody practice this because you're going to have a million questions come Thursday, and I'm going to say, I don't have time. I can't answer all these. What is it?
It's 8.029. Yeah, I got that.
Say it again. 0.364. Okay. Now, at this point, guys, when you get that in your calculator, you can hit second sign and then second answer, and it'll do it for you. You hit second. So the sine -1 comes up, and then hit second answer, and it'll come up. But what you're doing in your calculator is you're doing sine -1 of 0.364. And what do you get as a value? How big is this angle? 21.4. Okay. So angle B here is 21.4 degrees. Okay, fair enough. Let's go ahead and solve the rest of this triangle for our angles. If I know two angles, how do I find the third? You're going to add. So 42 plus 21.4 is how much? Okay, hold on. 42 plus 20.4 is how much? Or 21, I'm sorry, 21.4? 63.4. Okay, and then we take 180 minus that and get what? 116.6. Okay, so 116.6. All right, we'll finish solving that for the other side in a second. But let's figure out if a second triangle exists. This is how you do this. We're going to do 2 more examples from here. With the angle that you first find, right? We were given A, and then we found B. You're going to find the supplement. What does that word supplement mean? 180. Good. So I'm going to say 180 minus 21.4. Tell me what that is. What is 180 minus 21.4? I get 158.6. You guys agree? All right. So how would I find angle C over here? What would I do with the 2 angles right here? If I'm going to find the third angle, I have 2. How do I find the third angle? Add them and subtract from 180, right? So what's 42 plus 158.6? 200 what? 200.6, okay? So guys, if I said 180 minus that, what do I get? I get a negative, right? Yes or no? Can you have a negative angle measure? No. So what do you think that's telling you? You don't have a second triangle. What you do to find if there's a second triangle, you take the given, right? You find the first one you're looking for. Then you find the supplement, and then you see if there's a second triangle present. There's not here. So now we are like, oh, okay, good. We only have 1. So what information am I still missing? I found all the angles. What, I'm missing the side. What side? C. So how would we find side C with what we're given? What was our initial proportion that we used? Sine 42 over what? 22 equals, what's angle C? Side 116.6 over little c. And how have we solved every single one of these problems? You cross multiply, so 22 times the sine of 116.6 equals c times the sine of 42. And then what's the last thing we do? divide both sides by sine 42. Now, when I do this in my calculator, do I have to hit second sign, second answer? No, I'm not looking for an angle measure here. This is giving me a what? A side length. So what is this? What is my answer going to be here? What's 22 times sine of 116.6 divided by 42? 29.4, you guys agree? Yeah. Okay, so 29.4, and what are we measuring in? Inches. So you would tell me that this was 29.4 inches. Anytime you are given two sides and one angle, you have to check for a second triangle. In this case, there's only one triangle present. The reason why is right here. Go back on the video and watch this tonight if that confused you. We're going to do two more examples. But I need you guys, you have to practice this because you always have to check if there's a second triangle. So let's go now to example 5. Go ahead and scroll through your notes to example 5. All right, we're going to look here and we're going to say what information is given. Well, if you don't have a picture, what do you think I suggest you do? Draw one. Draw any arbitrary triangle, just not a right triangle. Label A, B, C. Doesn't matter where you put them. What matters where you put stuff? Angles and sides have to be where? Across from each other, right? So I know that side A is 12, so that's going to be right here. I know that side B is 31. I know it's going to be here. And they told me angle A was 20.5. Does everybody agree? So survey the information. What do I have? Two angles and a side, so I can just add and subtract? No, I have two sides and one angle. That means I could have one triangle, two triangles, or no triangle. There's a possibility I could have one, two, or none, so I have to figure that out. We always assume in this case that there's two. I'm going to say triangle 1 over here and triangle 2 over here. What is given? What is given in one triangle will be the same in the other. So what angle is given to you? Just the angles will be the same. So angle A in triangle 1 is 20.5. So if there is an angle, if there's a second triangle, this will also be 20.5, both degrees. So now we're going to go and say, okay, we're going to use the law of sines because we have enough information. I have an angle and its corresponding sine length, correct? Okay, so I have sine of 20.5 divided by 12 equals, what angle are we going to try and find? B. So we're going to try and find B in both. We're going to go methodically go about this. So how do I do this? I'm going to say, okay, well, it's the sine of B, I don't know what it is, over 31. How do we solve all of these problems? Cross multiply. So 12 times the sine of B equals 31 times the sine of 20.5. Good. Divide both sides by 12, right? What am I going to have to do with my answer here? Is this giving me the actual angle measure? No, this is giving me the sine of the angle measure. So I'm going to have to hit second sign, second answer. So what's 31 times the sine of 20.5 and that divided by 12? What do you guys get? You can tell me the decimal and then we'll convert it. What decimal did you get? Give me 4 decimal places. So 0.904, is it 7? Okay. Obviously, guys, that's not our angle measure. So go ahead and hit second sign. And then put that 0.9047. And what do you get for angle B? 64.7. Okay. So I found out that angle B was 64.7 degrees. Now you can go ahead and solve for the third angle, can't you? In triangle, so angle C. What would angle C be? How would I figure that out? You add, perfect. You add 20.5 plus 64.7 and get what? 85.2? Okay. And then what do I do with 85.2? I have to say 180 minus. So what's 180 minus 85.2? 94.7. Okay, I know for sure, guys, that one triangle exists. So we can go ahead and cross off the no. How do I figure out if there's a second triangle? Well, what did we do last time? We took the one that we found. And you do what? What do we find? The supplement. What is 180 minus 64.7? Tell me what it is. Tell me. 115.3. Does that tell me yet if I have a second triangle or not? No. How do I figure out if I have a second? What do I do with those two numbers? I'm going to add them together. Okay, so what's 20.5 plus 115.3? What is it, 35.8? All right, then what do I do with that? 180 minus 135.8 gives me what? 44.2? That is your angle over here. What happened, last example, when we added, got the supplement, then we added the two angles. What happened when we added angle B, A and B from the second triangle? It was bigger than 180, right? So right away when you say, oh, it's more than 180, you can cross off, say, oh, a second triangle doesn't exist. But in this case, do you see how when you added them together, it was still less than 180? So in this case, guys, how many triangles do we have? We have two. So now we have to find what missing piece. What else is still missing? We know side A, we know side B. We need to find side C. And we need to find side C in both triangles because it's not going to be the same. Go back to your original sign that you used. What was our original proportion we used? Sine of what? 20.5 over 12 equals what? We're going to say sine of 94.7 over C. In this other triangle, I'm going to use that same thing because that's the given. So 20.5 over 12. And then what information am I using here for C? Sine 44.2 over C. So if there is no triangle present, when you find the supplement and then add it to the given, it'll be more than 180. If there is a second triangle, you'll find the supplement, add to the given, and it'll be less than 180. So now you just say, oh, okay, the possibility of two triangles is apparent. So let's solve this one on the left. What do we do for the 9,000th time? Cross multiply. Good, you're always going to do that. So 12 times the sine of 94.7 equals C times the sine of 20.5. Then I do what? Divide by sine of 20.5. So in triangle 1, how long is C? What's up? Yep. Well, in triangle 1, how long is C? You guys agree with 34.2? Okay. So 34.2. And what are we measuring in? Meters. And then in triangle 2, we're going to do the same thing. Cross multiply. So 12 times the sine of 44.2 equals C times the sine of 20.5. Divide both sides by sine 20.5. And how long is C in the second triangle? How much? 23.9. Okay, 23.9. So in this case, there was two triangles. Now, guys, does anybody know the relationship between sides and angles in a triangle? The longest side is across from what?
The shortest angle.
The longest side is going to be across from the biggest angle. The smallest side is going to be across from the smallest angle. So think about this. You should be able to look back and see your proportions. In triangle 1, what's the smallest angle? A. What's the smallest side from what you found? What's the smallest angle? If you're telling me angle A is small, what's the smallest side? A, right? What's the biggest angle in the first triangle? C? What's the longest side that you guys found? C, all right? So you should be able to go back and kind of troubleshoot. All right, let's do this last example, and then I'm going to talk about area for a second, and then we're going to be done for today. All right, again, I don't like this picture, so we're going to pretend like there's no picture drawn. So we're going to do what? Draw one. Every time we're going to draw one. So here's A, B, and C. Doesn't matter where you put the A, the B, and the C. Just make sure that the angles and the sides are across from each other. So they told me that side A was 15, so I'm going to put it here. Side B is 25, and angle A is 85. So let's talk about the information that's given to us. Did they give me two angles that I can just add together and subtract from 180? No. If they did, then we'd know, oh, it's only one triangle. They gave me two sides and an angle. So it could be one triangle, could be two triangles, could be no triangles. So let's figure out what this case is. So go ahead and get it set up. We're always going to assume in this case that there's two. So what is the given angle? Because if it's in one triangle, it's going to be in the other. What's the given angle? A. Okay, so 85 degrees. So if there's a second triangle, A is going to be 85 degrees. So let's go ahead and find which angle. B. How come I have to find B? Why can't I find C? Because you don't have enough information to do that. So what was given? What's the proportion that's given to us? Sine of 85 over 15, good, equals what? Sine of B over 25. What am I going to have to do at the end here? Am I finding angle B with my proportion that's set up? Yes or no? No, I'm finding the sine of B, so I'm going to have to use the inverse. So go ahead and cross multiply. So 15 times the sine of B equals 25 times the sine of 85. Now what? Divide both sides by 15, right? So I get the sine of B. Tell me what the decimal is. Do that in your calculator. 25 times the sine of 85 divided by 15. What do we get? 1.66 what? 0? Okay. So what am I going to do in my calculator? Sine negative 1. So do that in your calculator. I want to find out what angle B is. What's sine negative 1? What's the inverse of 1.660? What do you guys get in your calculator? You don't have to keep doing it. What do you keep getting in your calculator?
No, it's not working. An error.
Why isn't it working? What's it saying?
Error.
It's saying error. Some of yours are saying domain error. What does that mean? What does that mean? There is no triangle. Some of you did it about 3 times. You're looking around like, well, why am I getting that? There is a possibility, guys, that with the information they give you, a triangle cannot be formed. So in order to show me that, you would have to get to this point. I need to see here, not that you just guess, no. You've got to get to that point to show me, oh, wait a second. With what they gave me, it doesn't form a triangle. So there could be one triangle, 2 triangles, or no triangles when you are given 2 sides and an angle. If they give you 2 angles, you just add it up, subtract, there's only one. It's fine. But when they give you 2 sides and 1 angle, you have to check for if there's a second one present or if there's none. If it's possibility that you don't get one, that's okay. All right, last thing I want to go over is area of an oblique triangle. This is quick. We're going to talk about another area formula tomorrow, and you're going to be given these on the quiz, so you don't have to memorize them. But if you guys had a normal right triangle, this is the base, this is the height, how would you find the area of a right triangle? 1/2 base times height, right? Or base times height divided by 2. But in an oblique triangle, are there any right angles? No. So you're going to have to do something different. Here is the formula. Area of an oblique triangle is 1/2 BC times sine of A, which is the same as 1/2 times AB times sine of C. Okay, what this is saying, guys. B and C in the first, right here. What are B and C? Sides or angles? Sides. And what is A? An angle, okay? And the second one, what's A and B? And what's C? An angle, okay? And this one, what's A and C? And what's B? An angle. So in each case, guys, because these are all the same things, what are the 2 things you need? Sides and angles. How many sides do you need? 2 and 1 angle. It is important about where they are. You need 2 sides, write this down, and the angle between them. Another way you can look at it is you need the angle that connects the 2 sides. But in order to use this formula, you need 2 sides and the angle in between them. The way that I like to look at this formula, I like to write it like this. As side times the sine of the angle and divide it by 2. You don't even have to worry about a fraction, just divide it by 2. If you want to put 1/2 at the front, it's fine. But you need 2 sides and the angle that's in between them, or the angle that connects them. So when you look at a problem like this, obviously it's already drawn for you. Just say they told you that this side was, I don't know, 152 meters. All right, think about the information you need in order to use the formula that we just talked about. In order to use this formula of side times the sine of the angle divided by 2. You need 2 sides and the angle that does what? Connects them. The angle that's in between. Does that 152 have anything to do with this problem? No, it's just there to throw you off. In order to use that area formula, you need the 2 sides and the angle that connects them, like it's in between them. So you literally, guys, would do this. 52 times what? 90 times the sine of what? 102. And then you would do what with all that? Divide it by 2. Throw that in your calculator. Make sure that your calculator does the numerator first. If you want to, hit 52 times 90 times the sine of 102. Enter. And then divide it by 2. That'll work. But 52 times 90 times the sine of 102. And on WebAssign and on your quiz, it'll tell you what's around to. What do you guys get? It's a big number. 2,000, what is it? 288. And then what are we measuring in? Meters, what, since it's area? Meters, if it's area, squared. Make sure you have your unit correct. So your WebAssign, right now, 6.1 WebAssign, you guys can get done. I think it's 7 questions. It's not long. You guys can get all of it done tonight. It is not due until Friday, but do not wait until Thursday night to do this. I need you guys to practice. Rewatch this video in order to find if there's a second triangle, that sort of thing. That can be a little confusing, that ambiguous case. But you guys are good to go.